Okay, so let's jump right in. Think about it. Every single day, you're making just hundreds of choices, right? What to wear, what to eat, which way to turn. But have you ever stopped and wondered, how does a computer make a choice? Well, it turns out it's actually not that different from how we do it. And it all boils down to one single fundamental idea.
Here, let me give you a super simple example. You look outside, and you see it's raining. What do? I mean, that's a condition, right? The rain. In your brain, it just instantly triggers a specific action.
Yep, you grab an umbrella. And that simple, logical step, that's the entire foundation of how computer programs think. Seriously, they check a condition, and then, based on the answer they get, they decide what to do next. It's really that simple. So, this whole process of choosing a path based on a condition, well, it has a name in the world of programming. We call it branching. And honestly, it's just like coming to a fork in the road and deciding, am I going to go left or am I going to go right, based on, where you're trying to get to.
Okay, so what does that actually mean in programming terms? It's pretty straightforward. Branching just means executing a certain set of instructions depending on the answer to a question. Like, is it raining? True or false? Is the password correct? Yes or no? Is the score high enough? Whatever the answer to that question is, that's what determines the path the code is going to take.
All right, so the absolute simplest way to make one of these branches in your code is with a statement you could probably guess. It's the good old if-then statement. It's designed for handling just one single, straightforward choice. And here's what it looks like, kind of the basic grammar for it. It all kicks off with the word if. That's followed by a question, or what we programmers call a conditional expression. If the answer to that question is true, then the program runs a specific chunk of code. Simple as that.
Let's just trace that flow for a second. First, the computer checks the condition, okay? If it's true, it runs the code. But what if it's false? Well, in this super simple case, it just skips that code completely. It just moves right on to whatever's next. It's a one-way street, An action only happens if that one condition is met.
So you can see the really crucial part here is that one question, that conditional expression. The entire decision hinges on it. And honestly, the quality of your question is what determines the quality of your program's decision.
Which leads to another great question, right? How does a computer even ask a question that can only be answered with true or false? Because, computers don't get nuance. They need questions with a super clear binary outcome. They need a yes or a no, which in programming we just call true or false. And the way code does this is with something we already mentioned, a conditional expression. Now, this isn't some deep philosophical question, it's just a simple comparison between two values. And that comparison, it's always built from three key ingredients. So what are they? You've got a variable or some value, a comparison operator, and then another value or value. For instance, you could have students score, then the greater than symbol, and then the number 50. That whole expression, score greater than 50, can only be true or false. There's just no middle ground. And this table here perfectly shows the tools we use to build those questions. There are really just 6 fundamental comparison operators. You've got your greater than, less than, equal to, all that stuff. And with just these 6 symbols, you can build pretty much any true or false question a program would ever need to ask.
Okay, so the basic if-then is great for sure. But what happens when you need the program to do something specific when the answer is false? What if not bringing an umbrella means you should specifically grab a raincoat instead?
Just look at the difference here in these two flowcharts. On the left, you've got that simple if statement. It's a single path. You either take it or you don't. But on the right, now we've got a real fork in the road. There's a separate path for yes and a separate path for no. This is way more powerful.
So how do we make that second path happen? It's with one single, really powerful word, else. By adding an else clause to our if statement, we give the program a plan B, a whole separate set of instructions for when the condition turns out to be false. So let's trace this new flow, shall we? The logic here is way more complete. The computer checks the condition. If it's true, it runs the code block after then. But if it's false, it runs a totally different block of code after else. Either way, no matter what happens, the program does something useful.
Okay, theory is great and all, but let's actually see how this works with a classic, super concrete programming problem. This one really shows off the power of if-then-else.
So here's the question, and it's a perfect test case, really.
any whole number you can think of is either even or it's odd. There's no in-between. It's a perfect binary choice, which means it is absolutely tailor-made for an if-then-else statement.
So how does the code figure it out? Well, it uses this really clever mathematical trick with something called the modulo, or mod, operator. All mod does is give you the remainder after a division. So if you divide any number by 2 and the remainder is 0, you know with 100% certainty that the number is even.
And this just shows the two paths in action perfectly. If our condition n mod 2 equals 0 is true, the program goes down the then path and tells us it's an even number. If that condition is false, meaning there was a remainder, it follows the else path and says it's an odd number. It just works. Perfect. So think about it. We've gone from a simple idea about grabbing an umbrella all the way to checking if numbers are odd or even. But the real takeaway, the big picture here, is how this one simple building block is the real start of all intelligent software. And that is the key insight. Branching isn't just some mechanical step. It's the thing that lets a program stop being just a dumb list of instructions and start becoming a dynamic system. A system that can react to what you do and make what feel like intelligent choices. And I really want that to sink in for a second. Every time you log into a website, that's an if-then-else checking your password. When an enemy in a video game spots you, that's an if-then-else deciding whether or not to attack. It's these tiny, tiny little decisions layered on top of each other millions of times that create the entire complex digital world we live in every single day. So, you now get the fundamental secret of how code makes choices. It's not magic at all, it's just pure logic. It's just a series of simple questions and answers. Which means the only question left really is, what kind of decisions are you going to build?